Hello, I've put together some notes from the last half of chapter 1. We have solving simple equations, order of operations, and polynomials, three of my favorites. Before we get started, I want to revisit the idea of the equal sign because it's the most important idea in algebra and solving equations. Now, when we have that equal sign in the middle, what we're essentially saying is that if I put the x plus 3 on one side of a seesaw and the 7 on the other side of the seesaw, they balance perfectly. And everything we do to the equation needs to also keep the balance. Have you ever been on a seesaw with a friend, or not a friend, and jumped off quickly? What happened to your friend? Your end goes flying up in the air and they go slamming to the ground. It's a little bit funny, but not very fair. So, likewise, we can't just yank this 3 off of this side of the seesaw because it wouldn't be balanced anymore. If we yank the 3 off by doing minus 3, we have to remember to yank a 3 off on this side too, so our friend doesn't go crashing to the ground. If we take the same thing off of both sides, it'll continue to be equal. And what we'll have left on the left is our x, and what we'll have left on the right is 7 minus 3, 4. And it's still balanced. So we're going to keep this equal side in the middle all the time, and think of it like our seesaw, and make sure we do the same thing on both sides, so our seesaw stays balanced. Now let's look over here at the x plus 4 equals 14 that I have. We want to get the x by itself. So to do that, we need to get rid of the 4. The only legal way to get rid of a plus 4 is to do a minus 4. The opposite of plus 4 is minus 4. And to keep it balanced, we need to do the same to both sides. Now, I'm going to recommend, if you're having a hard time keeping the correct things on each side of the equal sign, that you go ahead and draw a line down it. There's a hot debate about doing that. Some people think it's helpful, some people think it messes up your work, but go ahead and do it. So, over here, to get rid of the plus 4, we minus 4, and then we just have to do it on this side to keep it balanced. We're going to do plus 4 minus 4 equals 0, and then we're going to bring down the x. 14 minus 4 is 10. Our equal sign stays in the center. Now, of course, what's x plus 0? It's just x. So here we have x equals 10. I just added that step to make it extra clear, but you can skip it if you want to. Down below we have m minus 6 equals 13. We want to get the m by itself, so we need to get rid of the minus 6. The only legal way to do that is to do the opposite and do it to both sides. The opposite of minus 6 is plus 6, so we're going to plus 6 to both sides. I'm going to plus 6 over here. I'm going to plus 6 over here. Minus 6 and plus 6 cancel out. That was that 0 up above. And we have m, equal sign stays in the middle. 13 plus 6 is 19. Okay? Underneath we have 45 equals 9 times t, or 9t. The only legal way to get rid of the 9, so that we can get the t by itself, is to divide by 9. The opposite of times is divide. We're going to divide by 9 and do it to both sides. So you can write the divide by 9 sign, or you can write it like a fraction sign, whatever you prefer. Do it to both sides. 9 divided by 9 is 1. So we have 1t. And 45 divided by 9 is 5. Now 1t is the same as a t. So we have 5 equals t. Okay? Next we have order of operations, or PEMDAS. Some of you may have heard, please excuse my dear Aunt Sally. I prefer people envy my dope alligator shoes, because I think it's funny. However you remember it, you need to remember the PEMDAS goes in a certain order, and it stands for parentheses, exponents, multiply and divide, add and subtract. One thing I want to remind you though is that MD for multiply and divide goes from left to right. It's not necessarily multiply first then divide. It's any multiplying and dividing left to right, and any adding and subtracting left to right. Okay? Let's look at some problems down below. 18 plus 2 times 5. Remember that little star is what I use for times when I'm typing or emailing. We don't have any parentheses or exponents, but we do have multiply, so let's do that first. I am going to be very uptight about doing these in an orderly, neat, and tidy fashion so that your problems don't get mixed up. 2 times 5 is what I want to do first, and I'm going to put it right underneath and bring everything else down. Now, since there's just two things here, we can just do 18 plus 10 is 28, and we're done. Okay? Let's do the next one. And remember, this little fraction sign means divide when I'm typing or emailing. So we have 6 times 3 divided by 2 minus 5 plus 13. This is a good reminder of the left to right steps. So left to right is the direction that we read and write, remember. So we're going to do the 6 times 3 first, and I'm going to write it right underneath and bring everything else down. Now, divide is next, because divide comes before minus and plus, so we have 18 divided by 2. That'll come next. Now, we have a subtract and an add, and they go left to right. We don't do the add first, we just do left to right. So 9 minus 5 is 4. Put that underneath, bring down the 13. 4 plus 13 is 17. Take your time when you're doing these problems. I don't care how many steps it takes. If you do it in a neat and orderly fashion, you'll get to the correct answer. And it's worth it. Just be a little bit patient. Our last problem down here has a lot going on, but it's not that bad. We can handle it. We do have parentheses, but we have exponents inside the parentheses. So P for parentheses, we do that first, but inside the parentheses we have exponents and minus. We need to do the exponents first. So 3 to the second power means 3 times 3. We know that's 9. And 2 to the third power means 2 times 2 times 2. That's 8. If you don't believe me, check it on your calculator. We're keeping it in parentheses and we're bringing everything else down. Okay, we're not done with our parentheses, so let's take care of that. 9 minus 8, we're going to put it right underneath and bring everything else down. Now when we have a number right next to a parentheses like this, it means times. So that's the next step. Multiply is the next step. 9 times 1 is 9. Bring down the 18. And lastly we have 18 minus 9 equals 9. No problem. What do we have next? Polynomials. I love polynomials. Polynomials have terms, coefficients, constants, and degrees. Okay, what does that mean? Terms are the little chunks or nuggets, okay? So this is a term and this is a term. That's 2 terms. This is a term, this is a term, this is a term. That's 3 terms. This is a term, this is a term, this is a term, this is a term. 4 terms. That's a term. So this little 6m is a polynomial technically, but we call it a monomial. Mono meaning 1. Coefficients are the numbers in front of the variable. There it is. Oh, that's tiny, I'm sorry. The 6 is a coefficient, the 3 is a coefficient, the 7 is a coefficient, the 2 is a coefficient, the 3 is a coefficient, the 4 is a coefficient, the 6 is a coefficient. Okay? Those are the coefficients. Constants are the little numbers at the end that don't change. They're not attached to any variable. Constant means don't change, right? So there's one constant and there's one constant. Before this gets any messier, the degrees are the highest exponent. So let's look at this one first because it's the easiest to spot. 3x to the second power, this has degree 2. And this one has degree 5 because it's the highest exponent. Now these also have degree. What's the degree of these? Remember, if you don't see the exponent is 1. So those have degree 1. One thing that we can do with polynomials is evaluate them for some value of x or y or whatever their variable is. So when they say evaluate for x equals 2, it means wherever you see an x, put in a 2. So we're going to write down the problem and just, instead of putting x, we're going to put 2. I always put it in parentheses out of habit. I suppose you don't have to, but it just reminds me that that's the variable, and that's what I put in. So now we're back to order of operations. We need to do these exponent first. So we have 5 times 4 plus 8 times 2 minus 3. Did anybody ask why we didn't do parentheses first for this problem? Remember that when we're using parentheses in between two numbers like this, it really just means times, okay? Maybe that was a little confusing, but I know that we can handle it. Alright, so we did exponents first. Next we're going to do multiply. 5 times 4, we're going to put it right underneath. 8 times 2, we're going to put it right underneath. And we're going to bring down the minus 3. If you want to do this next part in one step, you can, but I'll just slow it down and do it in 2 steps. 20 plus 16 to remind us to do left to right. 36 and bring down the minus 3. And there we are. It's worth it to take your time, do all the steps, write them out. The more you put on the paper, the less you have to carry in your brain, right? That's what I like to say. The next one, evaluate for y equals 5. Y squared plus 3y plus 4. Wherever we have the y, we're going to put a 5. I'll try doing it again without using those pesky parentheses and see if it makes more sense. Let me know what you think. So we have 5 squared plus 3 times 5 plus 4. Here's where my y is and I put in a 5. Here's where the other y was and I put in a 5. Exponents first, right underneath, bring down everything else. Next we have a multiply in here. 3 times 5 is 15. Put it right underneath. Bring down everything else. This technically can be done in all one step, lickety split. It's all adding straight across, but I'll do it in 2 steps just as a reminder. Left to right. 25 plus 15 is 40. Plus 4 is 44. That's it. I hope that helps. Let me know if you have any questions.